this video is for Module 5, which is your graphing calculator review. In order to do this lesson and know how to use the graphing calculator, you need a TI-83 or 84 or a TI-Inspire. I'm going to show you on the video with a TI-83 or 84. If you have a TI-Inspire, there is within the Canvas site, which I'll show you right here under Module 5. If you click on it, there is a calculator tips and tricks sheet that you can use. And it's very basic, but it shows you a little bit about using both the TI-84, the TI-83, and the TI-Inspire. So at least it'll help you with graphing so that you can get refreshed. I'll also post another link that'll have a little bit more information there in case you need it. But Google is a good friend if you need help with the Inspire. I use Google a lot if I have a question about the Inspire calculator. This module will focus on graphing and building a table in your calculator, adjusting your window settings so you can see the whole graph, finding key points of your graphs like the intercepts and the maximum and minimum, and finding points of intersection. All right, so we're going to start here by just building a table in our calculator so that we can make a graph. So I have in A, negative x squared plus 4x minus 5. So when we graph this in our calculator, you should see at the top left corner of your calculator, there's a y equals button. There's a little box around it right now. When you click on that, you're going to type your equation in. We're going to type in negative. Now, we don't want the minus sign that's next to the 6. We want the negative that's down at the bottom right of your calculator next to the enter button. Negative, it's highlighted in red right now. X. X is up next to the green alpha button. Top left here, negative x squared, over on the left, plus 4x minus 5. Now, when I hit graph here, that's what the picture is going to look like when I put it onto the paper. Now, we need to know the points that we're going to plot, so we're going to go to the table. We hit the second key, which is the second to left button from the top left. So second, graph, top right, brings us to the table. And we can scroll through the table in order to fill in the values on our paper. So we're going from negative 1 to 5, so I'm just going to scroll down there. And I want you to hit pause or do this on your own calculator and copy this table over to paper. And we're going to copy this over. I have it on my paper here. And you should know, you've probably graphed parabolas before, that they're symmetric. So when we make these plots, that's why a lot of the points are repeating. Negative 1, negative 10, we'll go ahead and copy them over. 0, negative 5, and I did that wrong. Negative 1, negative 10. 0, negative 5. 1, negative 2. There we go. And here we start with our symmetry where all the points reflect. We can go ahead and connect, and that graph looks like a parabola. That is upside down. All right, let's try B. We have what's called a cubic function here. So let's go ahead. We're going to go back to the y equals and hit clear. It'll clear out the whole thing for you. This time we'll have x cubed. Now there's no cube button, so we hit x. We have to hit the caret sign, which is on the right under the clear button. That'll give us a little exponent to type through 3. Now I need to arrow out of the exponent so that I don't write in the exponent. X cubed minus 3x squared. Oops. Sorry, guys. There we go. Minus 3x squared plus 3. All right, now when I hit graph this time, this is a squiggly looking graph. That's what our cubic function is going to look like. Let's find the table by hitting second graph. And our table here is going from negative 1 to 3, so those top 5 points. So go ahead and copy those into our table on the paper. And we'll plot them. So negative 1, negative 1, 0, 3, and 3, 3. Now, those points look kind of goofy, but if we know from looking at our picture what the shape's going to look like, we can connect them. So it'll look something like this. We'll go up and turn and back up there. There you go, that's your cubic graph. So hopefully you remember how to graph and make a table in your calculator. That's part 1. Let's look at part 2. We're going to adjust the window. So I'm going to show you here what this means. I grabbed this little window box as a screen grab from your calculator. So let's type in the first equation. Y equals, says negative 0.5 x squared plus 10x plus 9. Now when I hit graph, I see only part of that graph. I know it's only part of the graph because it's an x squared, so it's going to be a parabola. Now here's the thing, I can't see the whole thing, so I have to figure out how to adjust it. So I'm going to hit the second button on the top row that says window. This is the screen that is grabbed onto the paper. I need to change the window setting. Now the x min and max tell me how far my left x-axis is going to go, left and right, and then the y min and max tells me how far up and down my scale goes. This is a little bit of a guessing game. When I look at the picture again, I know I need to go way higher than 10 in terms of the y-axis to see the top, and I have to go way out to the right on the x's to see the other x-intercept. So let's try, when I hit window, the x-min is fine. I saw the left x-intercept. Let's at least try 20 for the x-max. We can always go back and make it bigger. The scale, we can go by ones. I'm going to go by twos. You can go by ones, it's fine. But I like making the scale a little bit bigger as my x-axis gets wider. Y-min was fine. I could see the x-axis. Y-max, I can't see the top. So let's at least go up to 50, and I'm going to go by fives. So I'm going to hit graph. And oh, I can almost see the whole thing, but I'm not quite far enough out to the right on the x's and quite high enough on the y's. So we go back to the window. Let's change our x max to 30. We'll keep the scale at 2. And our y max, let's just go ahead and make it 100. And I'll make this go by 10 this time. When I hit graph, I can definitely see the whole thing. So what we're going to do is we're just going to copy, we're just practicing changing the window. We're not doing anything else fancy with this. So we'll keep this here. We can go back to the window and we're going to copy those numbers down. So we had our x min was at negative 10, the x max was at 30, and we went by 2s. The y minimum we had at negative 10, we went up to 100, and went by 10s. Now yours has a note in my key. You might have gotten slightly different numbers. That's okay, and I think these are slightly different maybe than what I had on the paper. It's not a big deal as long as you can see the whole graph. All right, let's try B here. So what we're going to do, I'm going to show you. We're going to go back to the home screen, right? The 10 by 10 grid. We're not going to stay at this. Every time we graph, we want to make sure we're at the standard window. So we're going to hit zoom, which is right in the middle, top center. And we're going to go down to zoom 6, which says standard. When I hit zoom 6, it takes me right back to the 10 by 10 grid. That's always where we want to start. That's like our home base for graphing. So let's clear out the graph and let's type in the next one. Negative 0.25 x squared times parentheses x minus 4 parentheses x plus 3. All right, now I'm at my home screen, so I go ahead and hit graph. And oh, I can see most of the graph. I just can't see the top. So I don't have to change the x's this time. I'm just going to change the y's. So let's adjust our window here. We just need to make the y maximum a little bit taller. Let's try 15. So a little bit higher, see if we can just reach the top. Looks like 15 is going to work. So that's all we have to do to adjust the window, is make the y's a little taller. So our x max, if we have to go back to here to copy, we were from negative 10 to 10, going by ones on the x-axis. The y min, we went from negative 10 to 15, and we also went by ones. All right, last one here. Try this on your own if you've been following along with the video. We're going to go back to the home screen, zoom 6, and clear out our y equals. So our last equation, x squared minus 14x plus 1. When I hit graph, I can see part of my graph again. I can't see the bottom, and I can't see the right x-intercept. So I need to make my y's minimum smaller and my x maximum bigger. So let's see, x max, let's just start at 20 again, see how this goes. We'll go by 2s. And my y minimum, I don't know, let's try negative 50 and go by 5s. We can always adjust. Oh, that was perfect, actually. That was a good guess. All right, we can see everything. So we can go ahead and write that down. So negative 10 to 20 for x's, and we went by 2s. And then on the y-axis, we went from negative 50. Oh, I changed negative 50. I went up to the y-max of 5. I guess I could change that. I didn't mean to change the y-max to 5. I meant to change the scale to be 5, which only slightly changes the feature. But went from negative 50 to 10, and went by 5. And you can have slightly different numbers, but hopefully you see how you can adjust the x's and y's so you can see the whole picture. Okay? So using those same window settings, right, in part 3, we're going to use the same equations, the same window settings. This time we're going to find the maximums, the minimums, and the y-intercepts. So since I already have C graphed on my calculator, let's start with C. X squared minus 14x plus 1. We want to find the value, the ordered pair at the minimum of my graph, the bottom. So to do that, your calculator can trace this for you. You're going to hit second, which is the blue key, second, and then trace, second from right on the top. You're going to choose option 3, which is minimum. Now, you see a flashing cursor on there. At the bottom of your screen, it says left bound with a question mark. You want to make sure that that flashing cursor is to the left of the minimum, which it is, so I can hit enter. Now it says right bound. I have to use my right arrow key to go to the right side of that minimum value. You can go a little farther over if you want, but I'm going to stop right there and hit enter. And then you have to guess. You have to end up hitting enter 3 times. One more time here. And it'll tell you that my ordered pair, that 6.999998 rounds to 7. So my ordered pair for the minimum is 7, negative 48. Now the y-intercept we can get from looking at the table. Your calculator actually can't trace the y-intercept. Intersect is different. We'll do that later. That's not intercept with a PT. So what I'm going to do is go to the table. You should know the y-intercept of any graph is where x equals 0. And if I look at my table, x equals 0, where y is 1. That's the y-intercept at 0, 1. Okay? You should also notice, we'll talk about this more later this year, that happens to be the constant on the end. One more thing from the table there. I could have seen that if I go down to 7 here, I have the ordered pair 7, negative 48. That was our minimum. All right, now to trace the x-intercepts, I need to do the following. I hit second trace, and I'm going to choose actually the number 2, which says 0. 0 is another name for the x-intercepts of the function. So my cursor is way at the bottom. I'm going to do the left x-intercept first. So I have to make my left arrow go all the way, or my cursor go to the left. Now this is a little hard to understand, so try your best. To the left means visually, on the left side here, I'm a little bit above. So when I hit enter, see how it draws that line a little bit to the left of that x-intercept? And then my cursor, I have to arrow over to the other side of the x-axis. Now when I hit enter, I made a line on the right of that x-intercept. I hit enter a third time, and it gives me the ordered pair. I'm going to round to, I don't know if it says, round to the nearest tenth. So I'm going to do 0.1. You can do 0.07 if you want. 0.10. So that's one of the roots. And then the other one, we have to do this all again, second trace. We'll go back to number 2. And we're going to go, we have to arrow all the way over to that right one. Now for this guy, the left bound is below the axis. So when I hit enter, the line is still to the left of that x-intercept. In order to do this correctly, I have to go to the right, which is over the x-axis, and hit enter. This tells me my other x-intercept is at 13.9. Now this scientific notation, 1e negative 11, I'll write it really down really quick. So if I have 1e negative 11, what that means is that you would have 1, remember the scientific notation, this is the same as 1 times 10 to the negative 11. So you would technically move your decimal place 11 to the left. 1, 2, 3, 4, 5, 6, 7. And fill all those in with zeros. That's what that rounded number is. It's really kind of dumb that your calculator uses this scientific notation. Why they can't just tell you that that number is 0, I don't know. But I hope you would agree that that decimal is equal to 0. That's why I can write 13.90. All right, let's go back to B. So we're going to have to retype the function from B into our calculator here. So we have negative 0.25x squared. We'll just work backwards. Parentheses x minus 4, x plus 3. And then I'm going to set my window how we had on our paper, which was negative 10 to 10, going by ones. And I think we went negative 10 to 15. All right. Yep, that was our picture. So we're going to trace again the maximum value. So the maximum here is this top right kind of curve. So we're going to hit second trace and hit maximum, which is number 4. And we're going to take our cursor over, again to the left of that maximum, and hit enter. Arrow until we're on the other side of it, hit enter again, and guess. That maximum is at 2.9, 13.7. Now the Y-intercept, again, let's use our table. Second trace, or second graph, I'm sorry, where x equals 0, y is 0. So that means I have an Y-intercept at 0, 0. Now one nice thing that tells us is, remember, Y-intercepts, or x-intercepts, so Y-intercepts happen where x equals 0. X-intercepts happen where y equals 0. So that means that 0, 0 is also one of my x-intercepts. For this graph, I think you can see, you can look in your table, these are actually the whole numbers. You can see that at x equals 4, y is 0. So that's another x-intercept at positive 4. And I also have an x-intercept here at negative 3. So these ones, because it just happens that their roots, the x-intercepts or zeros, are whole numbers, I could find them in the table. If I couldn't find them in the table really easily, I would have to go back to my graph and trace again, right? So I have to go second trace, choose number 2. I'm just going to do one of these here. I'll do the one on the right. So I would go to the left, which this time is a little above the axis. Arrow to the right, which is now on the other side of the x-axis. Hit enter and guess, and it tells you 4, 0. Now, really quick, I want to show you what happens if you don't do the left and right part correctly. So if I'm tracing the x-intercept and I'm right here, I hit click enter, and then I go just down 1. I'm not on the other side of the x-axis, but I'm a little bit to the right, and I hit guess. It'll give me an error, no sign change. That means that you didn't cross over the x-axis. You have to have one of your choices above and one choice below the x-axis to estimate the x-intercepts. All right, let's go back to A here. So I'm going to recalculate here, negative 0.5x squared plus 10x plus 9. Now our window, we went from negative 10 to 20, went by 2s, negative 10 to 100, went by 10s. Oh, we went to 30, I'm sorry. All right, so there's my graph. So we're tracing the maximum again. So I'm going to go a little bit to the left of the maximum, and then arrow over a little bit to the right. Right, and it tells me that my maximum is at 1059. All right, now let's try to find the Y-intercept. So again, we go to the table, look for where x equals 0, and it says the Y-intercept is at 9. So 0, 9. And if you looked at your graph, you could try to see if it was on the table. It looks like my x-intercept, the left one, is at a negative number. So if I go negative just a little bit, you can see right away that the y values are negative. So I can't really, like I'm not going to find my x-intercept, I'm sorry, from the table. It looks like it's going to be a decimal. So we're going to trace it. We're going to go to number 2, and we're going to trace all the way to the left here. So arrow to the left. All right, we are going to the left, so that's actually a little below the axis here. Hit enter. You see the line is to the left of that x-intercept. Go to the other side of the x-axis, hit enter, guess, and my root is at negative 0.9, and y is 0. All right, and then the last one. Trace the other root. A lot of clicking. At least it's a lot of clicking on the computer calculator. A little bit more. So the left bound this time is a little above the axis. So right here I'm a little above. Hit enter. I'll go out to the other side of the x-axis here. Hit enter again. And guess. So my root is at 20.90. All right. So that's how you find the key points on your graph. It's a little complicated, especially the x-intercepts, but the more you practice it, the better you'll be. Last one, finding points of intersection. So we're going to graph the system of equations. That means there's two equations, and then trace where they cross, where the solution is. So we're going to go back to our standard window, Zoom 6. And when we graph these equations, we're going to graph one at a time. So we're going to go the square root, second square key, 2x plus 5. And then on the line underneath, we'll graph the other equation. When I graph them here, I see that the graphs intersect. They intersect one time. So to find where they cross, I go second trace. This is where I use number 5, intersect. That means cross. Now, the nice thing here is I actually don't even have to move my cursor for this one. All I have to do is hit enter, because it's on the first curve, it's on the blue line. Hit enter, my cursor is now on the red line, so I hit enter a second time, and guess is the third time. And it tells me where that point is at 1.6, 2.9. And that's all you have to it. So let's try the next one. Y equals, we're going to have 3 times 2. Now the exponent here is where the x is. And the next one is negative 0.5x plus 6.5. There's my exponential, there's my other graph. So we'll trace this one. Second trace, number 5. We hit enter 3 times. First curve, second curve, guess. And our root trace is at 1/6. Now, if you wanted to check this, since those are whole numbers, those will be in your table. So if you went to the table, notice that x equals 1 down here. I have the same output of 6, which is showing you that that's where they intersect. They have the same output value, so that's the solution. All right, last one, letter C. We will have negative x squared plus 4, and then x squared minus 2x minus 8. When I hit graph, I see that those two parabolas intersect at 2 different points. So I'm going to trace the intersection. Now I'm going to go bring my cursor over a little bit to the left so that it knows I'm looking for the left intersection point first. Now I can hit enter 3 times. 1, 2, 3. And it'll find the intersection there is at negative 2, 0. Again, if I looked at the table, I would see at negative 2, the output is 0 for both. And then if I go back to my graph, I'm going to trace the other one. So I'm going to bring my cursor this time closer to the other pair of intersection. There you go. Whoops. Hit enter, enter, enter. Third time tells me that root is at 3, negative 5. Or that intersection point, I'm sorry. Alright, so you have some practice at the bottom. Just mix practice, graphing, changing your window, plotting points, finding intersection. Check the key on Canvas if you need some help, or ask your teacher if you're still having some trouble with this.